Okay, yeah. I will start in English, except somebody not.
Cool.
Okay. Yeah, welcome to this Spark KickOff meeting. We decided to rename our Hadoop user group to Spark and Hadoop user group because so many of you were interested in Spark, and we already had a meetup with Spark as topic. So yeah, and it's a big hype and fits very well into this user group. So we decided to rename it, and to celebrate this, we have some kickoff talks about Spark. Very short talks for people new to Spark, just to show what the whole environment of Spark, what the library offers you, and some of our experiences with Spark. So we would like to have in the next meetups maybe a lot of talks about Spark, if you have experiences, and to answer questions around Spark, like questions about distributed computing, why it's complicated, what's the problems with Spark if you want to set up a cluster, what use cases do you have with data which really fits for Spark, because often people don't have data which is big enough that you really have to set up a Spark cluster. So it would be interesting to see some use cases where Spark is really needed. The next meetup, for example, will be a comparison between Apache Spark and Apache Flink, which are two competing frameworks offering the same things maybe. And they will have a very fair comparison, I would say. This meetup is unfortunately already booked, fully booked, but I guess there's a waiting list, and as we see today, only half of the people are visiting, so I guess you should get a place. Yeah, then we would like to have meetups about cool libraries Spark is offering. This is the reason why we use Spark, because it has a lot of libraries for every use case. Yeah, this is one reason you must use Spark. So yeah, let's start with the short talks, and afterwards maybe we can meet. You can meet us who present today and can discuss in deeper detail the different topics. So we have slightly experience with Spark, also in real projects. Some presentations are more about yeah, what we learned for fun, but some are from experience. Meet us afterwards. Okay, then we start with Dieter, and maybe I can present in front. There's Sven and Amer, also from Consisto, having two talks today. And Dieter will start with Spark DataFrames, and yeah, all around Spark data. Yeah.
Data types, yeah.
Data types. Okay.
Hello, and very warm welcome to the Hadoop and Spark user group. My name is Dieter Kling, I'm a data engineer at Consisto, and I will be presenting today. Yes, a short overview of different data types used by Spark. So I will be using this Spark notebooks. This is Databricks Spark notebook. It's actually a nice way to do some documentation and code, and yeah, to combine them and to see some runnable code together along with documentation. So is it all about? You probably noticed that there are a lot of different APIs flying around. There are RDDs, DataFrames, Spark SQL, and datasets. And I will try to give an overview and to put them in a relation. It's also a historical thing. You can clearly see that it started with RDDs, resilient distributed datasets, in Spark 1.0, and it was and it remains a basic abstraction in Spark, and it represents an immutable partitioned collection of elements that can be operated on in parallel. Later on, in Spark 1.3, DataFrames API was introduced, and it was more natural way for working with structured data. So, and it's also well-known concept from other languages. And finally, this year, Spark 1.6 introduced extension on top of DataFrame API, which provides a type safety and object-oriented programming interface. And let's look at some examples. First, I will construct an RDD. Yeah. Okay. Okay. No, it's actually it's reversed. Okay. So RDD. What is it good for? It's good for a functional way of transforming the data, but it remains a collection of opaque objects. This is basically the main weakness, because you cannot optimize RDDs for further performance. We will create our schema using case class person, as you can see here with two attributes, and then slip over to the parallelized world of Spark by using Spark context parallelize call and passing in an array, and what we get is an RDD of type person, so it's statically typed. Further, we can work with it as with distributed collections, Scala collection, and apply some transformation, like for example filter, and then with collect we trigger the execution of transformation, so it will get materialized again on the driver as non-parallelized structure, and then after applying this and printing it, we see it. We will get a list of person objects. So for DataFrame, what is different with DataFrames? It's more. It's kind of similar to Spark SQL, and it's a way to work with transformation in declarative way. As you can see here, we can use existing RDD to transform it to a data frame by simply calling 2df, and then with data frame we can inspect it by using show. We can check the schema, and we can split some columns and basically slice and dice it. And this is a similar operation as shown with RDDs. You can see that here it's not statically typed. You have your transformation, or you have your predicates as strings, and what you get is basically a collection of rows as shown here, which contains the data, but not as an object-oriented way. Data sets. Again, we use the RDD, initial created RDD, to convert it to data data set. And again, here we are in back in object-oriented world and can have type safe access to attributes, and it's quite, the code is the same as with RDDs, but these and the result is also we will get the objects back, but it's closer to DataFrames than to RDDs in a way it organized, and we will also see what the benefits are. So Spark SQL. After we get a SQL context, we can use an existing data frame to register it as temporary table named Spark people table, and we can run a query against this temporal table, and the result of this will be a data frame again. So we can also inspect the execution plan. This is an not optimized execution plan, and here we generate produce a optimized execution plan. So the optimization is built in, and this is some syntactic sugar on top of this notebook, and it's basically the same as here, but in a much clearer way. So it's very powerful. You can really start at instant to work with data. So here are some examples how you can combine actually. What is very nice is that Spark SQL and DataFrames can be combined. It's two sides of the same medal, and you can go forth and back between declarative way of working with data using SQL, or yes, a functional way, building by pipelines and running transformations on the data. So it's this way the latter will be probably more convenient to programmers or people with programming background. And the SQL way is yes, more natural to analysts and so on. So, but the nice thing is really you can use both. You don't have to decide, and you can combine it. There's also really nice things like you can open a S3 file, Parquet file directly, or Parquet directory containing some distributions of or partitions of a Parquet file, and run queries against it, and look at the results. It's really nice. You can you don't have to write a boilerplate code. You can start just straightforward and use it. So what are the conclusions of this three different APIs, RDDs, DataFrames, and datasets? Well, RDDs still are there, and they will be there, so they remain the core component for Spark. But if you build on your applications, if you work with structured data, you should use DataFrames, and in the future probably datasets. Not probably, but yes, and yeah, data sets. So DataFrames. Again, just to summarize it, they are very flexible. They bring optimization. They bring built-in optimizations. Also for dynamic languages like Python and R. For example, here you can see a benchmark. They data frame called or executed in Python or Scala. They actually, yeah, they have the same performance. So it's amazing because yeah, there is no Python code executed. Unlike here, when you use Python Lambda functions and RDDs. So it's clearly a very nice abstraction which you can use in both languages. And yes, and it allows to combine the declarative and functional way of working with structured data. Datasets, well, datasets take both from the best from both worlds. Type safety from RDDs, which allows even further optimization. Yes, built-in optimization from DataFrames. So it's still experimental, but it will, yeah, quickly become a common way to work with structured data. Here again, some benchmarks. Datasets versus RDDs. Execution time, you can see datasets outperforms clearly the RDDs. Again, this is the data size. Due to memory compaction, you can really reduce the amount of data, and by this also speed up the processing time. And is especially performed is the encoders. So this is the serialization, new way to serialize the data. As you can see here, the encoders they just go through a roof. So just all this information actually, or most of this information what I was telling about is yeah, you can see here in this graph. Here you have RDDs, DataFrames datasets, and by parallelize you slip into the parallelized world of Spark by 2DF, which also you can make it call by implicitly. You convert your RDDs and DataFrames, and then yeah, basically I would say the most applications will remain in this area. But you can also switch to convert the data to a data set by applying S class name function or back again. And there's also other conversion possibilities for pandas, for example. If you are working with Python and pandas data frames, you have corresponding conversion methods. Yeah, that's all. Thank you for your attention.
So, hi everyone, my name is Sven and I work for Consisto, and I will also do a talk today about Spark streaming. So Dieter already talked a little bit about one of the APIs of Spark, but there are more APIs that you can use. And one of them is Spark streaming, which is pretty new, but it's maturing quite a bit, so I wanted to talk to you a little bit about Spark streaming today. So why do we even need streaming, right? Why do we want streaming? So right now we can see a trend going from data at rest to data in motion. So instead of having on your data warehouse or on your cluster a huge pile of data that will be batch processed, like with latencies of hours or days, you want to go to processing times of minutes or seconds. So instead of having like a batch architecture or a lambda architecture, you want to go to a streaming only architecture. So many companies that are doing that right now. So just two numbers from 2015 I found pretty impressive. So LinkedIn is processing 1.1 trillion messages a day using Kafka. And Microsoft is processing 10 terabytes of event data per day from the Office 365 product. So it's all about fast data, right? So it's not necessarily big data, it's fast data. So you have lots of input data streams coming at you at a very high speed, and you want to process it all. So at the end, you basically have the same challenges that you have with like big data, you have with fast data, right? So you want to process it, and for this you need a scalable architecture that supports this. And in the end, usually the goal is to generate some business real-time insights. So it's usually not real-time in a real-time sense, but it's usually business real-time. That means it depends on your business, right? So it can be minutes or hours, but usually it's something above the second threshold. But you want to have the insights pretty fast, not within a day, right? So how can Spark Streaming help with that? Spark Streaming is just one of the frameworks that you can use. Lars already talked about Apache Flink, and there will be a talk next week, I think, in this user group. So I won't go into details on comparing the streaming frameworks, I will just focus on Spark Streaming today. So taken from the website, Spark Streaming is a scalable, high-throughput, fault-tolerant streaming processing framework, and we will see in a minute what that means. So it's high throughput, but it's not low latency. Okay, I will come to that point later. So it's not a low latency message processing or stream processing framework. So if you look at the Spark ecosystem and all the APIs, you can see that Spark Streaming sits on top of the Spark Core API. So Dieter just talked a little bit about Spark SQL and DataFrames on the upper left. And Spark Streaming is also an extension to the Core API. So if you want to use it in your project, you have to explicitly define a dependency on Spark Streaming, and then you can use it. And it's the same with Amer. The basic abstraction in Spark Streaming is a D-stream. So what's a D-stream? A D-stream is a discretized stream, and it represents your continuous stream of data. And it does that by forming a sequence or a collection of RDDs, right? It's not the stream itself. You cannot process each individual message, but you get a sequence of RDDs, and those are just regular RDDs that can be processed with Spark. So if you look at the high-level architecture of Spark Streaming, it works like this. You have input data streams that can be anything from Twitter, from a Kafka stream, or a network socket stream. And each input data stream is associated with exactly one receiver. So that's a Spark Streaming input receiver. And you get some of the receivers you get out of the box when you use Spark Streaming, and you can very easily write your own receivers, right? And Spark Streaming is responsible for batching the input data. So Spark Streaming will, you can configure a batch interval, and when the batch interval is reached, so it's all time-based, when the batch interval is reached, all the input data that was received by the input receiver will become an RDD and will be handed over to the Spark Core API, and the Spark Core API will process this RDD in a normal fashion, like in a normal Spark application. And then you obviously have your output functions on the right, just as with the normal Spark API. And you can push results downstreams or do whatever you want with it. So D-stream is just a continuous series of RDDs, like shown on the timeline here. So now the interesting part is that you can do transformation on D-streams, right? So you have a D-stream API, and then you can do transformations on this API. Like for instance, in this example, you have a lines D-stream that can be lines from a log file. and you want to filter out the errors from the log files, right? So you would define a filter transformation on the lines dstream, and all the stateless transformations on the dstream API will return another dstream. So this is just like RDD transformations. They are lazily executed, and they form a DAG. And once you use an output action, like in a normal RDD, this will materialize, right? So the way to remember this is that you define your dstream transformations once before you start the streaming context, and then this transformation will get applied at each batch interval to each input RDD, right? So it's like a stamp. You define it once, and then at every batch interval, all the transformations get executed. So a quick look at the execution model before we dive into the code. Because it's kind of interesting. If you know how the normal execution model in the Spark cluster works, this will look familiar. On the left side, you have your driver program. This is where your code is, right? On your laptop or on some node in the cluster. And there you create a streaming context from a Spark context. So you have a Spark context, and you create a streaming context from it. And you can only have one streaming context per JVM, right? But you can define multiple D streams on this streaming context. And the way this works is that for each input stream you define, let's say Twitter or a network socket, there will be a long-running task assigned to one of the executors. And this long-running task is then represents one receiver and is responsible for receiving all the data. It's buffering all the data. And when the time comes to form the RDD is created and handed over to the Spark executing framework, right? And there's internally also like a buffer threshold. So what actually happens is that the data that is like received by the input receiver is turned into blocks and handed over to the block manager of Spark. And one copy of each block is copied redundantly to a second worker node. So if the receiver thread dies, then another receiver can take over and use the blocks to continue with the RDD. So this is the execution model. This is how it works. And what you can see from this is there's one nice mistake you can make when you start with Spark streaming is to allocate only one thread. Then this won't work because you need at least two threads, right? You need one thread for the driver program, and you need at least one thread for the receiver. So if you allocate not enough threads, this whole model will not work. So let's look at some code. I also prepared a notebook in the Databricks environment Dieter already showed. And because Dieter didn't show it, I want to show it very quickly. In the background, there's an AWS cluster launched with Spark 1.6.1. And all the notebooks we are running here the code gets executed on the Spark 1.6.1 cluster, right? So what I want to show you is a Twitter streaming job, right? So we will use the Twitter utils input receiver that comes out of the box with Spark streaming, and we want to receive tweets, and we want to extract the hashtags from the tweets. And then we want to make like a top 10 or top 20 list of all the hashtags, right? So I will make this a little bit bigger. I hope everyone can see this. So all we have to do is inside this creating function, right? So this is Scala code, by the way, if you haven't already seen it. And the first thing we have to do is create a streaming context. And we have to choose a batch interval. And the batch interval I chose for this example is 10 seconds. So every 10 seconds an RDD is created from the input stream, right? And we need some authentication, of course, so I'm using my Twitter credentials for the Twitter API. And then we can use the static method create stream from the Spark streaming library to create the stream. And this Twitter stream is a D stream. So this is a D stream object, and we can do transformations now. And the first thing we want to do is like get the text, so the text content from the tweet. Then we split up the words and we filter the hashtags. Right? And then we continue with each stream operations. So this is all lazy, nothing happens if I define this function. This will only get executed when I actually start the streaming context. So once we have our hashtags, we will do a simple word count, right? So this maps every hashtag to 1, and then we do a reduce function which just adds for every unique key the occurrences, right? So this is a simple word count. But it's not that simple because we don't use reduce by key, we use reduce by key and window. And what this does is it doesn't take every batch RDD, but you can define over your batch RDDs, you can define arbitrary windows. And the window I defined here is actually longer than the batch interval, and it's 30 seconds. And that means that another RDD will be created, and it will look back 30 seconds and contain all the RDDs that were generated 30 seconds ago. So this will actually include 3, in our example, it will include 3 RDDs. This is done automatically by Spark streaming, right? And then we finally stop with the transformations because we're happy. And we actually materialize the vstream with a for each RDD operation. That's like a collect in the streaming world. So for each RDD actually hands you the RDD and you can do arbitrary transformations on it. And what we do here, what we want to do here is just register a temp table. That's the same thing Dieter did with the DataFrames API. So I'm using this RDD, turn it into DataFrame, and it actually is just a pair of hash and how many times the hash occurred. So it's just a pair of hash and count. So it's a string and an int. And then we sort this by the count, right? And then we register a temp table, and this will register a table that we can use to query with SQL. And then we also output the top 10 hashtags to the standard out here, right? We have to tell the Spark context to remember everything for 1 minute because otherwise we couldn't inspect the temp table because the data would be gone, right? And then we just return the Spark streaming context. So all this creating function does is actually set up all the things, all the transformations and the DAG. Nothing has happened yet. And to start the streaming context, we use another method, get active or create, and we pass it this function we just defined. And this will look for existing streaming context because we're only allowed to have one. And if it finds one, it will use that one. And if it doesn't find one, it will create a new one, right? And then we start the streaming context. But I already did this before my talk, so we have some data, right? And we can look at the Spark UI of the cluster, hopefully. And what we can see up here is another tab. And this only appears when there's a streaming job running, and it's called a streaming tab. And here you can see the batches that we received, and I started this like 10 minutes ago, so we received 107 complete batches, and we analyzed 43,000 tweets, right? And what you can see here are all the complete batches. So these are all the batches that actually processed by using RDDs. And with that running in the background, we can query the temp table. And this is just a simple select query with a limit. And I did this like 10 minutes ago, and I think something with the VAMs was pretty trendy. So let's run this query again, and we see it's still the top hashtag. I don't know what it means, but maybe somebody of you knows what it means. Maybe it's a movie or something. But
if you run it in 10 seconds, it's going to update?
It's still updating, right? Yeah, but it's there's one thing I didn't show you, right? So we have a pretty large count here, right? So it's 419, but the code I showed you should only use the last 30 seconds, right? And good point. And so if you run this, like for every window interval of 30 seconds, the temp table would contain new values, and new values. And what you usually want, you want a longer trend. You want a stateful operation. You want to remember the top hashtags. And this is a pretty cool and new function of Spark Streaming 1.6. All you have to do is do another transformation, and that's a stateful transformation, and it's called map with state, and you pass it a function. And I already did this function before the talk, and it's called mapping function. And this is a way of Spark streaming to maintain state over all your streaming. And Spark will do this for you. So all you have to do is implement this function, put it in the D stream, and then from this transformation on, the D stream will be stateful. And that means it will remember for each hashtag a state of int. So this is a very simple example. We just add from this RDD window computation 20 counts of hashtag to the state object. Okay. And since I started this whole thing with this line here, with this transformation, we actually have the accumulated counts in here. So if I run this again, hopefully somebody will tweet this. You see it changes, right? So I shared the VAMs is now 439. And that's all I wanted to show you, and I think I already used up all my time. So thanks for the attention. If you want to chat about streaming architectures or Spark streaming, find me after the talks and we can have a chat. Thank you.
Okay, so I will continue with Spark machine learning, and I realized I forgot to introduce myself. My name is Lars. I'm also working here at Computer. And yeah, I will present you some examples about Spark machine learning. Spark was formerly called ML-lib, and now it's redesigned. This ML library is now just ML because they have a new concept of pipelines, machine learning pipelines. So the Spark machine learning library has already a lot of algorithms implemented, and I showed from the example of the scikit-learn algorithm cheat sheet, because scikit-learn is, I would say, was slightly copied by Spark. The pipelining concept, for example, was originally developed by scikit-learn, and a lot of algorithms implemented, shown in the cheat sheet, are now available also in Spark. So we have these 4 areas: classification, clustering, regression, and dimensionality reduction. And I think if you want to decide which algorithm fits for my data, you can have a look at this sheet and just to check what algorithm you should use, because there are plenty of algorithms and you can't know everything. So hopefully there will be some similar for Spark one time for all these algorithms available. So what I did, I loaded the same data from a Parquet file which Dieter used, and read it from Parquet, register it as a temp table, and can execute now my SQL commands on this temporary table. And we talk now about the New York City taxi data set. I don't know if everyone has heard about it, but it's a public available data set where taxi data from New York City is collected. This means the pickup places and the drop-off places of taxis, and number of passengers, tip amount. A lot of data is collected. Can I scroll? And I want now to have a short prediction, a simple prediction on this taxi data. So what could be interesting is to see how is the amount of tips spent by the passengers related to the fare the passengers have to pay. So we would expect a linear correlation between the tip given to the taxi driver and the fare of the taxi. So I just had a scatter plot which is offered by the Databricks notebook on DataFrames, and we would see our assumption is correct. We have a linear correlation with some outliers, and we could do this visualization just by selecting two columns from this temporary table. We had a small filter tip amount bigger than 0 and smaller than 10, and fare amount smaller than 50. So just to fit that it fits in the picture. So Databricks Notebooks offers a lot of different plot options for your data. In this case, the scatter plot was correct, but what would be also very interesting, I think, is histogram. If you want to visualize your data, and if you have a big data set, and you have a lot of other possibilities. So now we want to do a prediction. So we want to predict the tip the taxi driver receives from the fare the passengers have to pay. And for this, we have to transform the data. So a standard transformation on standard data frames would look like shown here. So we would filter the data, we have to add new columns because we need labels, which is the feature we want to predict, and the features from which we want to predict. So we have to transform our data frame. This would be the standard way we would do in Spark, but Spark machine learning has another concept again. It's called pipelining, and pipelining is very useful because you have to repeat the same steps of transformation and estimation maybe again and again for different parameters, for cross-validation, for different splits between training and test data. So most times you change the input data and run it through the same pipeline. Yeah, you have here two transformations in this example, and the last step here is a fit, the estimation. So I estimate a logistic regression model, and when I want to predict, I would do the same transformations, but I wouldn't learn my model again, but I would just do the prediction. So I would reuse the first two transformations of the pipeline and do the prediction afterwards. And so you can chain a lot of transformations with this pipeline and change parameters, as I said, for cross-validation if you are familiar with machine learning, or change the input data very easily. And additionally, there's a new framework on top of Spark which concentrates on the pipelining, which is called Keystone ML. I just saw the website, I didn't really test it, but it's definitely worth because this pipelining concept is very elementary for machine learning. So Keystone ML could be the way to go if you do machine learning with Spark. So in this example, I defined two transformation steps for my input data. At first, I do this SQL transformation I showed before. So I select the features from my data set which I'm interested in. And this is, in this case, tip amount. I also took the passenger count and the fare amount. And filtered here for all tip amounts bigger than 0. So I defined a transformer in this case. And I will show later how to execute it or who use it in the pipeline. The second transformation is a vector assembler. It transforms my data so it's usable by a machine learning algorithm or model. So it gets the columns which are my input, or defines the columns which are my input, and the column which is my output. I want to predict with the features, and the features called passenger count and fare amount, and I would want to predict a certain label. And the label is here my tip amount. So I defined it. So I have two transformations. And this one transformation I executed just to show it. So I have features, passenger count, fare amount, and the label, which is the tip given to the taxi driver. This label is what I want to predict. And now I set up a simple linear regression model. You can explain it, show which input parameters are available, how they are used. And next step you always do in machine learning is you split your whole data in a training set and a test set. This is also done very easily by Spark by using this random split function. And a percentage, so 90% is put into my training data and 10% in my test data. And then I use the training data. Oh, no, next step, I define my pipeline now. So to set up a pipeline is very easy. After you define your transformations, you set the stages you want to execute in the pipeline. So I have the taxi data selector, which was the SQL query. The training data assembler, which was building my training data as it's needed by the algorithm. And we have an estimator with a linear regression model. And then we just use this pipeline on the training data. So we call this fit function, which is the same, or which is available for every algorithm. So you could just, for example, change the estimator and call the same function, the fit function, because it exists for maybe random forest or other estimators. And this call to pipeline.fit executes the whole stage, so two transformations and the estimation. And the result is a model with the estimated parameters. And then I transform my test data and predict with the model. So the model transforms the test data into a prediction. And this is also a very cool feature, because this is just a transformation step. So you could use the result again for the next estimation. So you can increase your training data with estimated values. So you could chain a lot of estimators. So you have something like a meta feature, then the prediction would be like a meta feature, which can be used to have an even better model afterwards. So in this case, I just show my my predictions. So we have again here the input features, the label, which is the tip amount, and my prediction. And even with this only two features, the prediction is quite okay, I would say. So and I think it was very easy to set up. So you can predict the tip amount in this case very easily from these two features.
Can you directly plot your prediction and the original label in a scatter plot
Yeah, should be. Good try. Have to convert it in an SQL format.
Maybe
This is a data frame. Display?
Also,
Drumherum.
genau. Aber ich bin ja jetzt nicht
Okay, yeah. Okay, yeah. I don't know.
Bei den Plot Options kannst du die Colors noch einstellen und so. Dann sieht man es wieder besser. Okay.
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 Yeah, but it's somehow seems to be so. This line is quite one-to-one relationship. It's proportional. So.
Can you also show some evaluation metrics or RMC or something?
Yeah, that's available, but for this pipeline, the concept is slightly different. So
Or you can define it by yourself.
There is like a minimum squared error or something, some error function you can show, or some metric to evaluate. And there's also which you can use for cross validation. There are some evaluators for your model.
Yeah, minimizer or maximizer.
Yeah, and you can use these evaluators, which measure the quality of your model, for doing cross validation. But I didn't want to show it today because it's too much. Yeah. Okay, so how you could get started with Spark machine learning? Just use your laptop maybe. If you have a Mac, do install Spark. Get the Databricks Community Edition notebook. You have to register on the website and get onto a waitlist. But Sven told me he just had to wait 4 days, so maybe it's a try.
And it will be generally available in June or July or something.
Yeah, so this notebook is definitely good way to start. I don't know, and you get a small cluster with
6 gigabytes.
6 gigabytes. So okay, you can't have big data for analysis, but for showing some prototype, it's okay. You can get data from Kaggle, for example, which is very. If you don't know it, you should definitely visit the website and check their data science competitions and data they have. Panama papers are already available on GitHub, so you can check what you find out about your politics. And you can visualize the data again with this notebook, or there's also a free open source notebook. It's called Zeppelin Notebook. You should read the docs, read the Kaggle competitions, blog posts, and forums. They contain a lot of useful information about machine learning. Yeah, just put some graph from Panama papers to the end. So. Okay, that's it.
Hi, my name is Amer. I work for Consisto, and today I want to show a little bit what I worked with Spring Boot and actually integrating Spark into Spring Boot. Can you raise your hands? How many of you know Spring Boot or using it? Okay, quite few. That's not a problem. So for the ones who don't know, Spring Boot is a relatively new framework from the Spring ecosystem and Spring frameworks. It actually integrates many different frameworks into Spring ecosystem and tries to configure many frameworks out of the box. So before it was a really pain to configure everything to have an application working. And what I wanted to experiment and try to integrate Spark into Spring Boot, and so you have a Spring application, you have dependency injection, and you can actually start really fast with Spark and also with the Spring ecosystem. So let's show for the start. Okay, the Gradle build file. Okay. Let's Okay, so with, when you want to start with Spark, you actually have to put first all the dependencies, and it can, with Spring, it can be quite painful because their build is not so good, and then you have to exclude so many dependencies. And what you can do in Spring Boot, they actually provided many bundled dependencies, and what I did, I cloned Spring Boot I cloned the Spring Boot build, made some changes in with Spark, and hopefully it will get in a few months to a pull request. And so what Spring Boot does is it scans your class path, looks at your dependencies, and for example it sees Spark, and then it assumes you want to use Spark, and then it tries to configure things out of the box, so you can actually start pretty easy with some pre-configured properties. So what I did, where is it actually? Yeah, here. So this is actually a bundled dependency, Spring Boot start as Spark. So you just have to put one dependency from Spark, and you can actually start right away. And let's go into one class. Okay. Okay, so we have here a simple Spring application. We're creating some array, then we injected one service which delivers some apples. And let's start it. So for that, okay. So we go in this method, and before actually you have to create, for example, the Java Spark context, provide a configuration file, configure some basic properties, but here as we can see with all Spring things, you just auto-wire the dependency, and it's actually available, pre-configured, and you see it actually is already configured, and you can just put somewhere in your code Spark context. It can be the Java Spark context, it can be streaming context or SQL context. It's still a work in progress, but I have some things configured for now, the Java Spark context, and you can run it till the end, it passed. And another thing great with the Spring ecosystem is you have application properties. You have actually one properties file for the whole application. It can be from Spark to Hibernate to everything, and you don't have to write one configuration file, read it somewhere, then put it into the Spark context. It's actually out of the box integrated in Spring. Everything here is actually per default. When you start it, you don't have to, for example, Spring Spark master is per default local with a star, so it means it will be deserialized into as many cores as you have, but you can also configure it here, and you can also pass as command line properties. It goes here, and then it will be injected into the Spark context, which when you work with Spring, it's actually also with Boot quite easy to start with it. And so we can also here override it or not. It will actually work, but there is some more thing, one more problem. Where is it? Yep, here. So this part, this lambda, so we have here a Spark context, and this will actually be executed onto the worker nodes, and it has to be deserialized. It has to be serialized and deserialized to go to the workers, and in that case, we have this food repository. It's auto-wired with Spring's annotation auto-wired, and when you send it to the worker nodes, and it has to be executed, it will just be null because it doesn't have the Spring context, which was quite a problem. But thanks to my colleague Florian Rodler, he made some little hack, and you extend this auto-wire capable deserializer. For now, it's a little bad because you have to extend some class, but in the future, maybe it will be possible with an annotation. He actually just overrided the read object method from Java, which actually overrides the deserialization process, and he invokes the default read object, and after that he tries to in this class. Well, it's is it here? Yes. So it actually recreates the Spring context. If he doesn't find it, if he actually finds it, it doesn't do nothing and lets the application work again. So it's a little bit of a hack because when you deserialize it onto the worker nodes, it doesn't have the context and it has to be recreated for the first time. So hopefully I will try to make a pull request to the Spring community, and I don't know, in some months it could be actually be in Spring Boot and you can start with it. So that's for me. Thank you.
Okay, so I have one last topic. It will be short. Hopefully. So when we started with Spark, we had a lot of problems getting the cluster configured, Spark configured. I would say it's a configuration hell because we have so many options. It's not everything is documented. It's dependent on each other. So, and you have to know Spark very well that it runs stable. So when I started with Spark, I would say 5 months ago, my Spark monitoring looked like that. So no, like that. So a lot of jobs failed simply because it was out of memory. The driver was stuck with garbage collection. I did set the memory wrong, and it was a little pain to get it running correctly. It should look more like this. So every job runs smoothly, but Spark has this resilient distributed data set, so when a job fails or a task fails, it tries to re-execute this task. And so you see here we have 24 tasks which had to be executed on the worker, and 38 failed. So this 24 tasks which should be executed failed 38 times before all of these tasks were executed successfully. But this is built in Spark, this re-execution of failed tasks. But after a while, or if you have serious errors, you get something like that. So the whole job is failing, the whole stage is failing, and you can't resume it. Or Spark can't resume it automatically. So this was a lot of pain, and yeah, then we set up, also with the help of Florian, really deep system monitoring to see what's happening on our servers. And what we saw in the end was a lot of garbage collection at the driver, which blocked all the processing on the workers. So you see on the upper left, we have here 2 workers, and on the upper left, we have the driver. And when the driver is very busy doing something, the worker just does nothing and is stuck. So Florian investigated a lot about garbage collection and Spark, and in the end, we got to a system running very smoothly. So I can try to show it. Okay, I'm not logged in here. Yeah, but in the end, we got a curve which was very, so had a very even red zone for the worker. So the worker was very busy all the time, those workers, and the driver was not busy. And one thing we did wrong in first place was to have a worker also on the same server as the driver was running. So we decided the server where the driver is running should have no workers and doesn't block each other. So, and then it was running very smoothly. Again, we did monitor the garbage collection. We did a lot of garbage collection settings. And yeah, it was really hard for Florian, I think. But he managed in the end to have a stable job running 2 hours with 2 terabyte data and a few problems, no problems, I would say. So this is one part you have to keep in mind if you start with Spark, that you have to monitor your system, you have to see where the problems are deep in the application. And Spark's default configuration is not the perfect configuration, so you have to configure a lot, also the garbage collection. Another thing, I tried the Spark server, but I ran into a lot of problems, so I stopped to use it, and tried at first to have a Spark job stable without the Spark job server. Maybe now we will go back to Spark job server. So the Spark job server is a RESTful API to use Spark. So you can submit jobs via REST, execute jobs via REST, start a context which you can reuse. So you have an interface to communicate with your Spark cluster, and you don't have to log into the server and manually call Spark submit to start a job. And another thing we did, we set up our own cluster with Ansible, which was also quite handy. But of course you have other options like using EMR on AWS and connect EMR, or you set up again your own cluster with spot instances, which are quite cheap, or connect even EMR with spot instances. So there are a lot of options to set up Spark cluster. There are some Ansible scripts you can reuse to set up your own cluster. So you have to check which option fits best for you. And yeah, this was just a short overview. I won't go into detail with all these operational things. If you have time afterwards, we can show you our monitoring or our cluster, if you are interested. Yeah. So that's it so far from our short talks. Hopefully it was short. And now we can, yeah, have a beer, pizza, and so on. So thank you for listening, and yeah. And hopefully some of you feel free to have a talk in one of the next meetups. Doesn't need to be Spark, but yeah. would be great to hear about your experience. Okay, thank you.